I'm just gonna get mirroring going. I'm like accidentally open a downloads folder.
Browser history.
Like, really, you're into that? It's here, right? I suck at computers. Look at that handsome son of a bitch. All right. What's up, Poland? I'm Ken Wheeler, and I had a hell of an evening. It turns out when you put on this Callstack jacket, you just become like king of the nightclub. But yeah, I'm Ken Wheeler. I'm super American, and Ken_Wheeler on Twitter. If you want to read a bunch of trash. And I'm the director of open source at a company called Formidable. It's a Seattle-based consultancy where we do lots of fun JavaScript stuff. So the year is 2017, and we author complex applications in an interpreted, weakly typed language. And at some point, we're going to have to admit to ourselves that this feels unreasonable. I'm so sorry. But I'm not. Right? But it's okay, because there's a better way. And I'm here to talk about it today, and that's called Reason. Can I see a show of hands who's heard of Reason? All right, okay. Can I see a show of hands who's tried Reason? That's why I'm here today. So what is it, right? It's a new syntax and toolchain for OCaml. And it looks and feels kind of like ES6. What's cool is even though you're writing OCaml, the whole toolchain is developed around like NPM and Yarn, so it's like JS devs. It feels pretty natural as far as like installing dependencies or running things. And it can be thought of as JavaScript's typed, faster, and simpler cousin. So OCaml, you say. If you're not familiar with that, this is like my favorite slide I've ever made. So OCaml is a general purpose scripting language, or programming language. It's like it's a system language. It's also a meta language, and it combines functional, imperative, and object-oriented code, or at least allows you the opportunity to do so. And one of its stronger points is static types and type inference. So its type system is amazing. So you might say, as JS devs, why would we write something in OCaml as opposed to any of these other nice languages that are out there? So when you're not compiling to JavaScript, it's actually really fast native code. That's the first class right there, is that you're compiling to native code. Also, because it has that combination of the object-oriented and the functional, as opposed to more like purely functional languages, you get side effects, mutation, other escape hatches where a lot of these languages it's fun to write and pretend you're going to ship something, but these things let you actually ship something. And React itself was originally written in ML. It was a standard ML, and then was brought to JavaScript. So it's a natural thing to come back. So for that JavaScript story, why would you write Reason instead of actual JavaScript? There are actually a few reasons why you would do that. I told you I'm not sorry. Right? So again, at least my experience in JavaScript, right? Using types is like a bolt-on after the fact thing, and there's good things, but when it's a a natively supported thing, it feels like it plays a bit nicer. There's less friction. So the rock solid type system is a big one. There's also incremental conversion. One of the things that I liked about Flow was how you can kind of just add it piecemeal rather than have to just like rewrite your whole thing. And the same thing applies to Reason. Performance and size. So when it's compiled down to JavaScript, a lot of the time that JavaScript that it compiles to is faster than handwritten JavaScript, which is chill in my book. Also, the actual language that you're writing this in is bananas. You know, you're able to do things, you know, ES3030 features, but you know, you have language features. It's like RoboCop riding a holographic T-Rex. All right, so yeah, now I'm gonna try the daunting task of running through some Reason fundamentals with everyone. All right, so first off, we're gonna look at the primitives, right, which might look pretty familiar to everyone. You have strings, characters, integers, floats. You have immutable lists, which look like our arrays, and our arrays have these like pipes on the ends. Then you have tuples, which is my favorite word to say. You have records, and familiar-looking conditionals, you know, things like the ternary and Boolean operators. So writing it feels pretty natural if you're coming from JavaScript. Yeah. As far as like declaring variables, you have let bindings. So here, is this font size okay for everybody? Yeah. All right. Yeah. So here you can just kind of like just declare something, and then like in there inside of the I'm gonna let you finish conditional, you know, where you define bay. You know, that's scope to the block. So, yeah, the let scoping behaves the way you would think it would. Right. Now, the real funny thing, and this is something that you know, takes a little getting used to, but I ultimately enjoyed, is the module system, which is bananas. So there's no import export, right? If you're in JavaScript land, you know, we're doing all the import destructure from what have you. That actually isn't a thing, right? So a module is like a mini file or a namespace, and every single Reason file that you have in your project is a module itself. You know, if it's in your project, every other file kind of has access to that and can reference it at will. And the way that you do that is, you know, you follow the convention of making your file names camel cased. I'm not kidding. Yeah, so you make a camel case, and then it'll kind of like expose it as capital case. All right, so if it's like, you know, ken.re, it'll be like capital K-E-N. You know, if you do the cameling, then you know you'll get multiple capitals for two-wordy kind of things. Additionally, you can define modules inside of files, which gives you, you know, like namespaces inside of files, so you can get nested module stuff. Here you can see an example of like a bunch of Reason files just kind of hanging out in a directory. And all of these are modules, right? So if you have test.reason, like that's like the top file, and you do a let binding in there, like let module property equal thug life, then in your index, right, I could sit here and I could print and reference it with, you know, dot notation, like say like test.module property, and, you know, boom, thug life is right there. So I hope that kind of illustrates, you know, how this works a little bit more. If you have a nested thing, so right here inside of that same test.re file, I could say module nested, right, and then, you know, say the obvious inside of there. And then in your index, you know, again, you can access it the same way with the dot notation. You could say like test.nested.handsomefellow or what have you. Now, here's some fun stuff. So when you have these modules and you're inside of another file and you're referencing them, you can use this open keyword. And what that does is it'll expose all the internals of that module to the whole rest of the file. So if I open test, if I say open, it's gonna just load everything that's like the next level is just going to get loaded right into the scope, right? So I could say print endline just nested.handsomeffellow, not test.nested.handsomeffellow. Now this is like generally, I don't know if it's like frowned upon, but if you're going to do a global open, you should probably have a damn good reason for doing it. The alternative and preferred syntax is this, which is tight. So this is a thing, when I first saw it, I was like, what the fuck is this? But it's actually the coolest thing. So if you have like modules, which here essentially act as namespaces, you could use this syntax where you say like the module that you want to go to and then dot and then the parens. And what that does is any code executed within those parens is then within the scope of the module that initiated those parens, right? So in here I could say, print handsome fellow, and because it's in those parens, it's like reverse destructuring in JavaScript. It's bananas, and I like it. I think it's cool when you actually use it, in the course of writing things. You're like, oh yeah, well that's nice. So let's look at functions. So this might look pretty familiar ES6-wise, right? So we're going to say let add, and then you have this function keyword. We have 2 arguments, and then return a plus b, right? We're going to do a bit of adding. You're not seeing any parens, but parens are actually coming. Probably not too soon, but they're actually going to add parens in. And then using it's like this, right? You just have the function name and the 2 arguments, and it's going to go ahead and add it. The folks over at ReasonML HQ really like to make life easy, so they give you a lot of shorthand for things. So the function shorthand, where you don't need fun here, you could just say let add, and then the arguments, and then a plus b. So that's shorthand what a function would look like. Okay. Another thing that's kind of cool is labels, right? So here we have this function up top here, and this double dot syntax that you're seeing, that is labeled arguments. So here you can return, first, and then this little exponent thing, that's an operator used for string concatenation. So if you're wondering what the hell's going on right here, whenever you have 2 strings and you're concatenating them, that's the operator for that. So that's not weird. But yeah, here it doesn't matter the actual position of the arguments as long as they're labeled, and then it'll return action Bronson. So the biggest thing in Reason is the type system, and it's certainly my favorite part. So you could do normal types like you might be used to doing in TypeScript or Flow, where you could just say int is fine. Also, you could do this right here, where you can type out a record, which is essentially an object. You could type out that shape. So I could say person, name string, agent. Now here, if I go and I try and define this record, which is pretty clearly going to infer this type here, because I've provided the string shut up for age and not an int, it'll sit there and it'll complain about it. And that inference is really one of the more powerful things when you're developing. I'm a big fan. Variants are something completely new. So variants are simultaneously a type and a data structure. Here I can define this type status here. So it's a type, right, that has these these different what essentially turn into variables, and they actually take arguments as well, and they're super powerful when you're actually coding, especially when combined with pattern matching. So here, we could say status is idle, loading, or error. Where in JavaScript it would be you'd rely on a string for that or something, or is loading, is idle. So you could set fetch status to idle, and then with pattern matching, which is the jam. Here, so yeah, switch in Reason is a little bit different than you might be used to in JavaScript. You see switch and you're like, ah. Well, I don't know, maybe not. Maybe you use Redux a lot and you've come to terms with it. But yes, switch in Reason is a fundamental, really common thing where you do this pattern matching, which is super expressive and powerful. So here you can match on these, whoop, oh, crazy fingers. And then you can match on the different variant types. And for example, if it's an error, it'll load out. Oh shit, So you have fun. So that's cool. And we're sitting here, and you can make like native systems code, things like that. But we're all here to do some JavaScript. So let's talk about how that works. All right. So Reason and Camel for that matter is compiled to JavaScript using a project called BuckleScript. Right. It's written at Bloomberg, and they're a smart bunch of folks. They compile the OCaml to the JavaScript. What's funny about this is it's probably the most readable compiled JS I've ever seen in my entire life. So you can really go through what it's compiling, and it's not difficult to read it. It's also it compiles it in a way that most of the time it's faster than handwritten JavaScript. So that's certainly a plus. And it has probably the best interop story I've ever seen. So I'll show you exactly how that works real quick. So use this external keyword here. So this is like the React Native linking library, and I want to, if that's not bridged out, like I want to expose that. So you would say external, and then you would name, open URLs, what you want to use. You have your arguments here, and then what it returns. Unit is like a concept of like null or blank in Reason. So it doesn't return anything, so it returns unit, but it takes a string. So then here, we have our method name, and then you use this BuckleScript syntax here, BS module React Native, BS scope linking, right? So this would be like saying like, import open URL from React Native linking, right? And that's how that works. But this is your JS interop, so this is how the OCaml knows that open URL is that, and that you're defining what type of argument it takes and what it's returning, which is important because if you're doing like a string thing, you're kind of just defeating the purpose of a type system. So you definitely want to define these honestly. So on to Reason React, which is why we're here today. So Cheng Liu put together Reason React, and it's wild. This is what it looks like. If you're used to writing regular React or regular React Native, this might be a little wild looking at first, but after you write it for a little while, you're like, oh wow, this is like pretty simple and nice. So here you define your component, right? You say let component equal Reason React, and when you include Reason React, it's added globally, so you can just reference Reason React or any of this stuff at any time. Also, Reason supports JSX first class, so you don't have to worry about that. So here you have your component, and here's stateless component, but you can also have like, stateful component, or a couple different things like with retained props or what have you. And then the argument is the name here, and then you have this function right here, which is the important one. This is essentially your class or create class or stateless function name. It's called make. So you say let make, and typically you'd have maybe a props argument here, and then children. You spread component in here. The Reason supports rest spreads and destructuring, just like you'd be used to in ES6. Then your render function here, you return a thing kind of like you would in regular JavaScript. However, certain, when you're actually rendering out text, certain types need to get converted to string, right? So, and you need to convert strings to text elements. So here you're seeing if I have hello world, I need to call Reason React string to element. You would see that in other places where if you have a counter and an int, you're gonna convert the int to an element or a string. Okay. And then when it comes time to actually render this. Yeah, so you have a React DOM rendered element with ID. You have your element, and then this ID is what matches what it's actually going to render to. Right? I'll show a little example of props. So same component setup here, but here we have this function labeled argument message, which is just a prop. So in here I can say Reason React string to element message, and then if you give that a prop and messages there, that'll just come in. And the type system is going to infer that that's a string based upon use here, so you don't really need to do that explicitly. Type it up there in the arguments. State's a little different than what you're probably used to if you haven't seen this, so don't get all weirded out. We've been making stateless components thus far. Here we have Reason React stateful component, which you have to do when it has state. So you see here we have the initial state. So this is how you set that, right? It's a function that returns an initial state, which can be like an object with keys, or I can just return 0 here. Bless you. So you have a concept of an updater, which if you've ever done Elm, kind of, it's not the same, but kind of feels like that. So let's just go down here back before we review all this business. So if you have a button and you want to do like the count on click, it has self, which is like passed right here as an argument. It's like this, but not really. And on there you can call self.update. And self.update is like this.setState, almost. Right, it's set up a little bit differently, but you would pass it an update function. So the update function is on click, and we're here in on click. Because a button got clicked, right, you have this event here, but you're not really going to do anything with it. And then you destructure out reason react state, which is actually in self here. So this is really just self, and you're just destructuring out reason react state from self. And what you return is a reason react update. So here I'm saying reason react update and then saying state +1. Right, so you're taking the existing state, you're doing a +1 and returning that. So if you've ever used like functional set state or something like that, that's essentially what's happening here. And you see like it says like reason react update, and that might look a little funny. But when you get into it a little bit more, and you have like updates going, like you have things like reason react no update, so you can modify things in the state without explicitly forcing an update, which is interesting and different from how you might do it in React. So that is state, and on to React Native. All right. So if you want to do React Native with Reason, it's pretty similar, but you need to use the actual bindings for React Native so that you don't have to type that all out yourself. And the folks in the ReasonML community put together an awesome library, and it's called BS React Native, Buckle Script React Native. And if you go here to the ReasonML community organization, they have a lot of things actually pre-bridged for you. So if you want to write a real app, there's a lot of things that you would normally use that people have already done these types for. In the process of doing my stuff, I actually had to type a bunch of things out, and I'm a terrible person and shitty programmer, so I haven't actually contributed those types back yet, but I promise I will eventually. So this is, like the actual React Native experience is very similar to what I was just showing you with React. If you've I'm pretty sure everybody in here's done a little React Native, and coming from React, as far as the differences between the two, you're like, oh wow, it's like writing the same language. So yeah, it's like pretty much what we had before, but we're using views and text. It's crazy. But here's the little thing that's different and that I really enjoy. Specific to React Native and specific to that BS React Native thing, is that when you do styles, right? So first of all, when these things are bridged over and then exposed into Reason, a lot of the time the people that are doing it are smart and good at Reason, unlike myself. So they are going to expose it in the way that you would want to do it in Reason, not the way that you'd want to do it in JavaScript, right? So you're going to have APIs that you're familiar with that are a lot easier to use in this kind of setup, but it's going to be way different than what you might be used to. So here, this is how you do, this is how they bridged style sheet create and actually leveraged Reason features to make it awesome, right? So here you have style sheet create, and then we do this thing that I was showing before where you kind of like spread that scope. Missing something here, but yeah. So you have the style, and then if for like the wrapper here, you call style, and then this is a list of properties that essentially makes up the style. Two things to note, and that's why these two particular properties are here. Almost all of your number values are floats. You very rarely use a standalone int. And for a lot of these properties, they use this little backtick like enum syntax here, so that for certain properties that will only take certain things, things that you might have been using strings for previously. Now they're essentially like language class enums. So when you're writing it out, you're going to get completion on certain style keys. Like if I do like vertical align, it'll give me like a little list of things that it could possibly be in React Native, because they've typed it out that way. And then also it's sound, because if I put in like vertical align margin or something like that, it would be like, dude, margin's not on here, or it wouldn't even let you do it. So that's fun, right? So I'm gonna get to this, but before I do, does anybody want to see some Reason appery? Alrighty, so I'll just tell the quick story of this app. I have a couple minutes here. I'm happy to announce that I put the first ReasonML React Native app in the App Store, and it is the only Reason app in the App Store right now, and it's also the best Reason React Native app. Until somebody else comes along, but right now I have the best Reason app in the App Store, so I feel pretty good about that shit. My mic cut off? That happens. Yeah, so I'll tell you the story about it, right? So at Formidable, we ran the Seattle JS conference, and I emceed it, and everybody was like working really hard for it, and I just had to run my app on stage. So I'm sitting there like 2 weeks before, like, what can I do? And I was like, dude, we don't have a fucking app, really? Okay. I was like, I'll make an app. So normally like in the course of my work, like I don't know if I'd like be like, hey, team of 8 people, let's like let's use Reason on this project, No, that's kind of a hard sell unless everybody knows it. So working in isolation, I go and do hipster shit by myself. So it was an opportunity to try some new things. So I decided I wanted to do it in Reason, and in doing so, I had a really good experience. And if I was going to push something to the App Store, I didn't want it to be bullshit. I was like, if I want to, if I'm going to sit here and build a Reason React Native app, let's make some reasonably non-trivial stuff. Yeah. So here is the Seattle JS Conf app. Right. It's an RN app. We have our lists and stuff. And I wanted a fancy animation. You see me bitching on the internet about things you can't do on the web. And I'm like, so I always want to make these flashy things. So when you click this, it'll pop open this modal and then return there. So it'll pop out from wherever it is on the screen. It's kind of like shared animation type thing. So that wouldn't have been fun in any language, but it was interesting in Reason to get that going. So yeah, so this is the app right here, and I'll tell you how I did it. Not there. Okay. So if you want to do some React Native Reason, here's how to do it. So you can just create React Native app, which sets it up with Expo, and you're having a good time. Head down to your package.json. You'll probably want to install BS Platform, BS React Native, and Reason React as dependencies. And then you set up this BS config, which is your buckle script config file. So you set up the name here. Can everybody see this font size wise? Huh. Can anybody not see it? You can't see it? Okay. How we looking? Was that a thumbs up or more? Okay. Well, we're gonna just go down just one. All right. Yeah, so in here you do your buckle script settings. Now here's so this is a new thing, the BS super errors. So they just added like Elm level errors to Reason. So you screw up and it's like, hey, maybe you meant to do this. Do you want a cup of tea? So it's a really good time. It's really pleasant. Before it felt like it was just kind of like it's like a jerk, it's like, pff, but now it's nice. And then in BS dependencies, so anytime you add any of these bindings, over here in BS dependencies, you're going to go ahead and add that. So you add Reason React, you add BS React Native. And then before I was talking about the modules, how like if you just create a file, it's in scope. Is that like the digital cane off the stage? Okay, all right, I'll make it quick then. You define like the directory where those files live, and then if you have subdirectories within there where it should look, you do subdirs here. But I mean, that's really it. That's the long and short of it. There's just one more thing that I'll show, which is the actual entry point, and then that's really what it takes to set the project up, and it's pretty well documented. So like here's your actual app.js, which is still JavaScript, right? And we have our root, which is written in Reason. So see this right here? This is the only ugly thing, but this is the magic of how it happens. You say import component as root from lib.js root, right? What you're doing is you're importing the compiled JavaScript. You're not actually importing the Reason ones, but now they have a Reason loader. So when I wrote this, that didn't exist. But I digress. And then in your root down here, where is my JS export? You just need to do a JS interop export, and you're all set. But yeah, that's probably not super applicable right now. One thing that I neglected to say is that you want to add build scripts for buckle script builds. You have build and watch. So when you run like npm start or something like that, you're also going to want to concurrently with that run your buckle script builder. So anytime you make an edit to any of these Reason files, you're good to go. And what this actually looks like here is you have stateless component. Here's like some styles. This is what a regular component looks like. I'm gonna get my ass off stage, but I just wanted to show you something cool because I didn't do an example of like list iteration, which is like an interesting one, and it shows my favorite thing in the whole entire world. So here, like you list.map, right, and then we have these things that we're iterating over, but. In Reason, right, you can't just do the array. You have to do array to element, right? So it'll do a conversion of an array and then actually render that. So I'm sitting here iterating through these items, and then you have these forward pipes, and it's the shit. Right here, you basically list concat, and then you convert the list to an array, and then Jesus fucking Christ. And then you call Reason React array to element, and then you feel like you're fucking writing Haskell or something, and it's awesome. If you have any questions, just tweet at me nicely, and I'll respond anytime. Except apparently in between like 9 and 10 this morning. Thank you so much, guys.